Find the Jacobian for the functions u is equal to yz by x, v is equal to zx by y, w is equal to xy by z. Okay. So the Jacobian can be written as like this: j is equal to dou u v w by dou x y z. Okay. That is, we have to differentiate all these functions with respect to x, with respect to y, with respect to z, and then write the determinant of that partial derivatives. Okay. Let us see this. Jacobian can be expressed as like this: the first row contains partial derivatives of u, that is dou u by dou x, dou u by dou y, dou u by dou z. Okay. So these are the partial derivatives of u which are in first row. The second row contains the partial derivatives of v, dou v by dou x, dou v by dou y, dou v by dou z. Third row contains the partial derivatives of w, dou w by dou x, dou w by dou y, dou w by dou z. Okay. Now let us substitute the partial derivatives. So we have to differentiate u with respect to x partially. Okay. Here x is a denominator. With respect to x, yz can be treated as constant. Okay. So keep aside yz. We have to differentiate only 1 by x. What is the derivative of 1 by x? Minus 1 by x square. And yz is there. So totally this is minus yz by x square. Okay. Next, dou u by dou y. Again differentiate u with respect to y. Now y is a numerator. Okay. So treat z by x as constant. Derivative of y with respect to y, it is 1. Dou u by dou z. Now we have to differentiate u with respect to z. Here z is a numerator, so that y by x is constant. Y by x is treated as constant. We have to differentiate z with respect to z. So it is 1. So these are the partial derivatives of u. Now dou v by dou x. Okay. Here x is a numerator. So treat z by y as constant. And derivative of x is 1. Dou v by dou y. So in this case y is in denominator. So treat zx as constant, and y is in denominator means the function is 1 by y. So what is the derivative of 1 by y? Minus 1 by y square. And already zx is there. Okay. So totally it is minus zx by y square. Dou v by dou z. So here z is a numerator, so treat x by y as constant. Derivative of z with respect to z, it is 1. Okay. So these are the partial derivatives of v. Next, w. Dou w by dou x. Here x is a numerator, so treat y by z as constant. Derivative of x is 1. Dou w by dou y. Y is also a numerator, so treat x by z as constant. Derivative of y with respect to y is 1. Dou w by dou z. Now in this case z is in the denominator, so treat xy as constant. Z is in the denominator means our function is 1 by z. Okay. 1 upon z. So derivative of 1 by z, which is equal to minus 1 by z square, and xy is there. So totally this is minus xy by z square. Okay. So we have to take common x square, y square, z square. Okay. So 1 by x square, y square, z square. So take this x square as common from the first row. Take this y square as common from the second row. Take z square as common from the third row. Okay. Now the first row become like this. Okay. So minus yz. Here x square is there. Here there is no x square. 1x is only. So the remaining is like this. xz. Okay. It become xz. Here also only 1x is there, but we take x square as common. So it become xy. Okay, this is the first row. In second row, we take y square as common. Okay, but here y is only, so this can be written as yz. Here y square both are coincide. It is equal to minus zx. Here only one y is there, so this can be expressed as xy. In third row, we take z square as common, but here only one z is there, so this can be written as yz. Second term also contains only one z, so this also can be written as xz. Here z square both are coincide, therefore this is equal to minus xy. Okay. Now we take yz as constant taken as common from the first column, and xz is taken as common from the second column, and xy is taken as common from the third column. Okay. So take yz as common from the first column, xz is taken as common from the second column, xy is taken as common from the third column. Okay. Therefore yz from first column, xz from second column, xy from third column. Denominator contains x square, y square, z square. Okay. The determinant is, the remaining determinant is, okay. So we take yz as common from here, we take xz as common, we take xy as common. Now the remaining is minus 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1, okay. Minus 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1, okay. So here y into y square, so cancel y square in both numerator and denominator. Z into z square, cancel z square. X into x square, cancel x square. Okay. Now we have to evaluate the two denominator determinant. Okay. Along first row, we have to expand the determinant along first row. Minus 1 into multiply these two elements. Minus 1 into minus 1 plus 1, minus 1 into 1, 1. Next, minus is in the formula. Minus 1 into, multiply these two elements. 1 into minus 1, minus 1, minus multiply these two elements. 1 into 1, 1, plus, okay. Third element in the first row, 1 into, so multiply these two elements. 1 into 1, 1, formula minus, minus 1 into 1, minus 1. So minus minus plus 1, okay. So totally this is the expansion of determinant along first row, and this is equal to minus 1 into 0, minus 1 into minus 2, plus 1 into 2. Minus 1 into 0, 0, minus 1 into minus 2 plus 2, 1 2 is 2. So 2 plus 2 is equal to 4. Therefore finally the Jacobian is equal to 4. Okay. Thank you.